Hey, if you are new here, this is Chandan and you are watching the learning field. So this is the lecture 3 of our numerical analysis lecture series. Okay, so you all know that we are continuing the numerical analysis lecture series for GATE exam, for CSIR NET exam, and for any state level SET exam. We specially focused on GATE, and this lecture series is also helpful for CSIR NET and any other state level SET exam also. Okay, so this is lecture 3, and in lecture 2 we discuss the bisection method and the secant method. Okay, for the numerical solution of transcendental and algebraic equations. Okay, so in this lecture we will discuss the fixed point iteration method and the Newton-Raphson method. Okay, so let's start, and before starting, okay, so if the lecture series is helpful, then please give a like to this video, share with your friends, and subscribe the channel. Okay, so let's start with fixed point, our third method, which is fixed point iteration method. Okay, so it says that in this method the equation fx equal to 0 is reset in the equivalent form x equal to phi x. Okay, so we suppose if there is a equation, suppose x cube plus 3x plus 1, this is equal to 0. Okay, so we rewrite this equation as in the form of this x equal to phi x plus 0. So we have to determine the function phi such that there are such a certain condition or phi. Okay, let us comes to that conditions. Okay, so that a root alpha of the given equation satisfies alpha equal to phi alpha, that is the point alpha remain a fixed number under the mapping phi. Okay, so assume that phi x is continuously differentiable and sufficiently number of times in the initial interval, differentiable in sufficient number of times in the interval a0 b0. That is this is the initial interval of convergence. Okay, such that for x belongs to a0 b0, phi x also belongs to a0 and b0. Okay, now it directly comes to the iteration formula of the the what method, fixed point iteration method. Okay, so the iteration formula is this one, is the iteration formula xn plus 1 equal to phi of xn. Okay, so condition of convergence, so this is very important for the fixed point iteration formula, and this gives how we can choose the function phi. Okay, so see, phi dash x is less than 1, this is the condition of convergence in the interval a0 b0. So we choose the function phi such a way that in the initial interval mod of phi dash x is less than 1. This is the condition on phi, and phi is sufficiently number of times differentiable. Okay, so and now if we gives the estimation of error of this method, then this says that if x n plus 1 be the n plus 1th approximation of a root alpha of fx equal to 0 and epsilon n plus 1 be the corresponding error, then we know that epsilon n equal to alpha minus xn, and mod of epsilon n plus 1 equal to this. You can see, just this is simple calculation. Okay, so now the iteration converges using this phi dash xi n, where xi n equal to what? Xi n equal to minimum of xn alpha, the value in between minimum of xn alpha and maximum of xn alpha. We take this function xi, and we take this a certain number p, real number p, which is less than 1, and mod of xi n, phi dash xi n is less than this, less equal to this number or this certain quantity which is a real number less than 1. Okay, so now if we calculate simply mod of epsilon n plus 1, these are the simple calculations, you can see it, and this is less equal to, we get this one. Okay, and from this we can get the mod of epsilon n plus 1, which is less equal to p by 1 minus p into mod of hn, where mod of hn equal to what? This xn plus 1 equal to xn plus hn. This gives the value of hn, that is value of hn, this is equal to xn plus 1 minus xn. This is the value of xn. Okay, and this is known as the error equation of fixed point iteration method. Now we comes to the order of convergence of this method. Okay, so assume in general phi dash alpha, if alpha is a root, phi double dash alpha equal to phi to the power p minus 1th derivative of alpha, this is equal to 0, but phi of p of alpha is not equal to 0. That means this is a root of order what? This is the order of convergence, that is the method is order of p, that means the root is of order p. Okay, so then the iteration converges, and we have limit n tends to infinity epsilon n plus 1 by epsilon n power p, this is equal to phi to the power p alpha by p factorial, which is not equal to 0. Since phi n or xi n, since xi n tends to 0 as n tends to infinity. This shows that the order of convergence of the iteration is p, and asymptotic error constant, that is the value of c, which we already discussed. What is c, asymptotic error constant, in the first video, I think, in the video theory of errors. Okay, so this term is very important in now in these methods. Okay, which is equal to phi to the power mod of phi to the power p alpha by p factorial. And this is just some calculations, you can avoid or you can skip this calculation. You just remind these main things are made important formulas using of this method. Okay, now there are 4 types of geometrical meaning of fixed point iteration method. 4 types of situation can occur. So first one is if mod of phi dash alpha lies between 0 and 1, then these types of situations occur, which is suppose here we take 4 types of graph, and you can see it in any book of numerical analysis. 4 types of fixed point iteration method schemes or geometrical meaning of 4 different types of in case of iteration formula or fixed point iteration method. Okay, so this is convergent for mod of phi dash alpha lies between 0 and 1 and -1 to 0. That means what? That means mod of phi dash x or phi dash alpha which is less than 1. So in this interval only the fixed point iteration method converges, that is -1 less than phi of alpha, phi dash alpha is less than 1. So here 2 cases, that is from the right side of 0 1 case, and from the left -1 to 0, that is left side of 0 in 1 case. These are the simple geometrical interpretation, you can say. Okay, so you can see it, and it is divergent when mod of phi dash alpha is greater than 1, and divergent when mod of phi dash alpha is less than 1. So in these 2 cases, the iteration method or iteration scheme divergence, you can see it very easy way. Okay, these are the 4 types of graph in which this mod of phi dash value of phi dash alpha is less than 1, less than -1, greater than -1, and so on. These types of case here I just take, or you can see in any book of numerical analysis. Okay, so now if we take an example, fx equal to suppose 10 to the power x plus x minus 4. Okay, so now we have to choose what? We have to choose x equal to phi x. Okay, so x equal to phi x, how we can choose? So we choose x equal to phi x equal to log of 4 minus x. Okay, so we choose this value from this equation by phi x, such that mod of phi dash x equal to minus 1 by 4 minus 1 log 10, which is less than 1. That's why we choose this function phi. And you all know that this function is also sufficiently number of times differentiable, so that's why we choose this function as phi. Okay, so there are 2 conditions. One is sufficiently number of time differentiable phi in the interval, and second one is mod of phi dash alpha is less than 1. These 2 conditions implement on phi. Okay, or to obtain phi we have to see these 2 conditions. Okay, satisfies, then we choose the function as phi. Okay, so take x0 equal to a0 equal to 0.5 and b0 equal to 0.6. I take this example from a book. Okay, so this is a simple example, and here the initial interval is 0.5 to 0.6. so mod of phi dash 0.5, which is minus 1.2, and mod of phi dash x is minus 0.1 by 0.13. Okay, so table, if we iterate some schemes, or if we calculate some iterations, okay, so we see that this is the 0th iteration, xn equal to this one, and this one is the value of phi xn, that is where phi of xn equal to what? Xn plus 1, this is equal to phi of xn, and this is equal to what? This is equal to the log of 4 minus x. Okay, log of here 4 minus xn. Okay, we just put the values after 1 by 1 the value of xn, and we calculate xn plus 1. Okay, then we calculate the value of xn this, and we calculate by putting the value of xn and calculate from this function this one. Okay, so we proceed this process, and here I take these 3 iterations. Okay, so see here the value of xn and the value of xn plus 1 are same up to 3 decimal places. Okay, so if we have to calculate the roots up to 3 decimal places, then you can stop the iterations here. Okay, so if we need the further correct up to 4 decimal places or 5 decimal places or 6 decimal places, then we have to proceed further. Okay, for the exactness, or for to get the error or to get the error is minimum. Okay, so we have to proceed, or we have to calculate some iterations further. Okay, so this is the technique to solve the methods or fixed point iteration method, which is a very important method in case of solving the numerical solution or in case of solving the algebraic and transcendental equation numerically. Okay, so now we comes to the next method, which is Newton-Raphson method, and this is the most important method of the numerical solution of algebraic and transcendental equation, because from this method the questions from GATE exam or any CSIR NET exam or any state level SET exam must comes, or you can say in which the syllabus numerical analysis included. You can say or you can think that one question must comes from this section, Newton-Raphson method. Okay, if the questions comes from this chapter. Okay, so this is most important method. So Newton-Raphson method is an iterative method in which the iteration is produced by the following consideration. We have for alpha equal to xn plus epsilon, 0 equal to f alpha equal to f xn plus epsilon, we just put the values of alpha, so which is equal to, we expand this by Taylor series expansion. Okay, so this one. Okay, and we take these terms up to these terms, and this xi n equal to maximum, minimum and maximum, this value you can see it. We take these values from the iteration method. Okay, and one more thing is that Newton-Raphson method is nothing but a fixed point iteration method. This is a particular case, it just comes to the topic or to that point. Okay, so neglecting the term containing epsilon n square, we get an approximation hn to epsilon n given by what, fxn plus hn f dash xn equal to 0, or what, hn equal to minus fxn by f dash xn. Okay, then by setting xn plus 1 equal to xn plus hn, where this is the value of hn, we get xn plus 1 equal to xn minus fxn by f dash xn. So this is the iteration scheme for Newton-Raphson method, which is very important, and this iteration scheme is valid for what, valid for single root. Okay, single root or simple root, simple roots. This is the iteration formula for a single root or for a simple root. Okay, now and we comes to the iteration formula for in case of multiple root also. Okay, you have to read the Newton-Raphson method for multiple root also. Okay, because a questions comes from directly comes from that topic or that content in the GATE exam. Okay, so let us comes to an shorter version of these formulas and convergence, rate of convergence. Okay, just few minutes. So let a0 b0 be an initial interval containing the only root alpha of the given equation fx equal to 0 in which f dash x has the same sign. This iteration may be started with x0 equal to a0 or b0. This is a simple condition. Okay, so the iteration scheme is a particular case of fixed point iteration method in which the equation fx equal to 0 has been written as x equal to phi x equal to x minus fx by f dash x. So I just say that the fixed Newton-Raphson method is a particular case of fixed point iteration method. So you can remember this thing, that this type of questions are important for any interview. Okay, based on numerical analysis. So this is the small questions and the important questions. Okay, so that phi dash x equal to fx. So if we calculate the phi dash, then phi dash x equal to fx f double dash x by f dash x square, because we just use it that phi dash x phi dash alpha equal to 0 here. Okay, so then condition of convergence of the fixed point iteration method, we just put the value of phi dash x equal to this, so we get this is the condition of convergence, mod of fx f double dash x is less than mod of f dash x square. Okay, so this is the condition of convergence for Newton-Raphson method, which comes from the fixed point iteration method. Okay, so fixed point iteration method and Newton-Raphson method are two very important method of numerical solution of algebraic and transcendental equation. Okay, so geometrically, what is the meaning of Newton-Raphson method? Geometrically, the meaning of Newton-Raphson method is that the point at which the tangent to the curve y equal to fx, that is this point. Okay, so point xn fxn, so this is the point xn fxn. Okay, this is the point xn fxn cuts the x-axis at xn plus 1. So this is the tangent. Suppose this dotted line is the tangent and which cuts the x-axis at xn plus 1. So the equation of this tangent, which is equal to passes through this point and xn plus 1 and 0 point, this is the okay, this is the point. So the tangent at the equation y minus fxn, this is equal to f dash fxn into x minus xn. Okay, so this is the equation of the tangent which intersect y equal to 0 at x equal to this point xn minus f of xn by f dash xn, which is equal to, we take here the value xn plus 1, and this gives the iteration scheme of Newton-Raphson method. So this is the geometric meaning of Newton-Raphson method. Okay, cuts x-axis at this point and tangent has the equation this and intersect y equal to 0 at this. Okay, so this is the iteration scheme of Newton-Raphson method. Accordingly, the Newton-Raphson method is known as the method of tangent. Okay, so since this Newton-Raphson method comes from the concept of tangent, so this method is also known as the method of tangent. Okay, now the rate of convergence, you just see these calculations once. I don't go to this calculation. So xn plus 1 equal to, so this is the scheme. We put the value xn equal to xi plus epsilon n and expanding this xi plus epsilon n and f dash xi plus epsilon n in Taylor series expansion and at the point xi, and we obtain this one epsilon n plus 1 equal to this. You just go through these calculations one. You got the calculations, or you get the calculations in any book of numerical analysis. Okay, you just go through once. Okay, so epsilon n plus 1 equal to, we get at the last line half into this. So this is equal to epsilon n plus 1 equal to c into epsilon square, where c equal to this, which is known as the asymptotic error constant. Okay, so neglecting the higher powers of this, so since this is the order of epsilon square, therefore the Newton-Raphson method has order of convergence 2, that is, it is second order convergence or it is quadratic convergence. Okay, so this is the order of convergence of Newton-Raphson method. Now we comes to a comparison using a table of the 4 methods we read today's class and the yesterday's class. That is the 4 method: bisection method, secant method, iterative method, fixed point iteration method, and Newton-Raphson method in a table only. Okay, the important things. So this is the table. The method is bisection method. Iteration formula is this one: xn plus 1 equal to xn plus xn minus 1 by 2, either xn minus 1 or xn plus 1 or xn plus 1 xn enclose the value. You all know that what is this case. Order of convergence is 1, that is, it is linear convergence, and reliability, it is surely convergent. Now this is secant method. Secant method iteration scheme is you just write this table for your future purpose. Okay, so this is simple, a table and table of content, and this table gives you the 4 methods, their iteration formula, order of convergence, and reliability. Okay, so xn plus 1 equal to xn minus 1 into fxn by fxn minus f of xn minus 1, and the order of convergence is 1 plus root 5 by 2 or 1.618. No guarantee of convergence, reliability if not near to root. That is, if you can't take the initial approximation near to the root, then this does not guarantee that by using the secant method you get a solution or you get the approximate root. Okay, so in this case your guess your guess carry a very important role in this method. Okay, so fixed point iteration method, this is the iteration scheme: xn plus 1 equal to phi of xn, order of convergence is 1, and here in this case also same case, no guarantee if you if you are not taking the initial value of the root near to the original root. Okay, so if you are guess wrong, then this method does not guarantee that this method converge. Okay, this is the case. Now we comes to the most important method, which is Newton-Raphson method. So there are 2 cases particularly, and these 2 cases are most important case. Okay, so one is if the root is of multiplicity 1, that is a simple root, then xn plus 1 equal to xn minus fxn by f dash xn. This is the this is the scheme. Okay, iteration formula or iteration scheme, and order of convergence is 2 here. And in case of multiple root, the iteration scheme is xn plus 1 equal to xn minus m into fxn by f dash xn if the root is of multiplicity m. Okay, and in this case the Newton-Raphson iteration method is order of convergence is 1, that is, it is linearly convergent in case of multiple root. Okay, and the reliability is convergence is sensitive to the initial value. It is also the same case. first converge if starting point is near to the root. Okay, so if you choose the initial approximation or initial choose of the root is closer to the root, particular root, then it is very fast converge. But if you are not taking the choose, or if you are not choosing the root near to the approximate root or near to the original root, then it is does not guarantee that this is converge obviously, but the process is very long method, okay, or very laborious method in that case. Okay, so this is the topics, and this ends the 4 methods which are in GATE syllabus. The first one is bisection, second one is secant, third one is fixed point iteration method, and fourth one is what? Fourth one is the Newton-Raphson method. Okay, so this ends today's class. Okay, so if you like the content, then please give a like to this video, share with your friends, and subscribe the channel, okay, if possible, because we are very close to 1K subscriber. Please like, comment, share, and subscribe with your friends if this content helps you a little bit. Okay, so this ends today's class. Thank you. See you again in the next video. Thank you.